Hi, welcome to an Arduino step-by-step course by Robojax. In this lecture, we're going to learn how we can control two DC motors using L293D chip. We learn how to just turn on and off a motor, then we learn how to control the speed of a motor, then we learn how to control the motor in both directions. Now, in this video, we are using advanced code. We have customized it and made it very easy to use. Now we will be controlling two DC motors, and we will be using all four drivers of this L293D chip. Here is the logic diagram and the driver diagram. This has been taken from the data sheet. I've added the motor so you can understand it easily. We are using two drivers for one motor. One driver is connected to one wire of the motor. The other driver is connected to the other wire of the motor. And between the two drivers, we have one enable, which we will send the pulse width modulation signal. And these two drivers, when one is high, the other is low. In order for the motor to rotate in one direction, in order to change the direction, we change the one that was high, making it low, and the one that was low, making it high. And the same thing for the other one. The red color shows the Arduino pins that I'm using for this lecture. And here is a complete wiring diagram. On the breadboard, all the wires that were there have not been changed except the wires from Arduino. These three extra wires have been added with this motor, with comparing to the previous lecture. Pin 8 have been connected to pin 10. Remember, from here to here, that's pin 8. Pin 9, that is pin 10. So 8 have been connected to the input of one driver, and then 9 have been connected to the input of another driver. One driver is on this side, one driver is on this side. The output of this driver is this pin, and the output of this driver is this pin. 16, 15, that is 14, and then 9, 10, 11. 11 and 14 are the output. And then pulse width modulation comes from pin 10 to this enable pin, which is pin 9, pin 11, and pin 14. These two wires. And here is the wiring on the breadboard. I've removed the motor to make it look simpler. These wires have not been changed. This orange, green, and yellow, which have been connected to pin 2, 3, and 4. I've connected three wires here to pin 8, 9, and 10, which I've shown you on the wiring diagram. The same color have been applied. We have gray, pin 8. From this gray, this has been connected to pin 10, because 8, 9, and that's pin 10. And white from pin 9 goes to pin 15 on the chip, and the last pin, pin 10 is black. That is the pulse width modulation, which goes to the enable pin 9 on the chip. Let's call this M2. Have been connected to this pin 3, and pin 6. As before, this has not changed. The wires, doesn't matter which wire you connect, that when you connect it, it will just change the direction. So if you don't like the color in a certain direction, just swap it. I've been connected now to pin 11 and 14. Let me now explain the code. This portion is exactly the same as before in the other code that I just shown you, and I've added a second driver for the second motor. So these two drivers, 1A and 1.2, have been used for one motor, and 3A and 4A have been used for the second motor. We have defined pin 8 for pin 3A of the driver, pin 9 for 4A, and pin 10 for enable 3.4. These two are for internal use. In order to avoid confusion, I have defined CC W and CW for 1 and 2. Every time we need to send a command, we just type CCW or CW. Change this. Make sure for enable 1, 2, select a pin that is pulse width modulation enabled, and for enable 3, 4, also select another pin with pulse width modulation capability. Otherwise, it will not work. Inside the setup, this was exactly the same as before, defining the output and enable pin, and I've added 3 extra line for 3A, 4A and enable 3, 4. All of these pins are defined as output. Here inside the loop, we are using custom function that I've written for this purpose. It's called motor, and it needs 3 parameters. The first parameter is the motor number, which should be either 1 or 2, and the second parameter is the speed of motor and pulse width modulation value in Arduino term, which is from 0 to 255. And then the last parameter, the third one, you have to type CW or CCW, clockwise or counterclockwise, whichever direction you want to rotate the motor. In this line, motor 1 rotates at 255 in clockwise direction for 5 seconds. Then we go for the motor 2 at 170 pulse width modulation value in counterclockwise direction for 5 seconds. And then here we send, for motor 1, we send 0. This 0 pulse width modulation means stop the motor. This doesn't matter because when you stop the motor, you're stopping motor 1. Doesn't matter in which direction you want to stop it. And then again, we control motor 1. So these are just different examples to control motor stop or start, and these are the values. Now let me explain this function, which I've written it below here. This is void. It means it has no return value, and the name is motor, and we have 3 parameters. Those 3 parameters, the first one from the top, that when you are sending, for example, 2 to 55 CW, the 2 will arrive here and will become motor. We call it motor as soon as it receives. The second one will be called pulse width modulation, the 255 or 170. And the third one, CW or CCW, will be called the direction, DIR. And then this function ends in here. So I put here to / with motor to tell me that the function has ended. First, we need to control drive 1 pin, drive 2 pin, and enable pin. Every time we want to control a motor, we need to use 2 drivers, driver 1 and driver 2, and I call them drive 1, drive 2 pin, and enable pin. We also need an enable pin to send the pulse width modulation. So we define them as an integer. Pay attention, all these values are integer. And we first check if the motor is number 1. Then for this pin, we assign pin 1A to this value and pin 2A to this drive 2 pin, and enable 1, 2 to the enable pin. We have 1 enable pin which will control the motor. And then also we define this text here, string motor title, which has no value. Here we are defining this value, we are assigning this value to this variable. If the motor is not 1, it means else it must be 2. Then pin 3A will be assigned to this pin, and pin 4A will be assigned to this pin, to control pin. And then enable 3, 4. So for motor 1 we use EN1, 2, and for motor, if it's not motor 1, for motor 2 we use EN3, 4. To just remind you that we have defined these pins here. EN3, 4 means pin 10. This portion will make our variables ready. Now we check the direction, this direction that comes as CW or CCW. We have defined them here. CCW is 1, CW is 2. And here we check if direction is 1, which means CCW, then from here to here, all of this will take place. Now let's see what happens. Using digital write, we control the drive 1 and drive 2. The value depends on the motor. If it is motor 1, we will get this value assigned to this. If it's motor 2, this value will be assigned to this. So we select the pin, and we send the low, and select the pin, and we send the high. So high and low are all together for 2 drivers, and the motor will be rotating in CCW now. And if we pulse width modulation is 0, then we select this title, which means motor 1 or motor 2, depending on the type of a motor, and then we print this stopped because the value is 0. Else we print the motor title, which is this title, and then we type CCW, and after that we type print the value, the actual value that we sent at the end. Now this was if the direction was equal 1. Else then we have to control the two drive, changing the high and low differently. If you pay attention here, they're low and high, and in here, because it's different direction, high and low. And then the same exact type of text for CW, we type different values and we type different text. So this is all to make sure that for CW we print one type of text, for CCW we print different type of text with a proper speed. And after all this, the drive in pin, which is drive enable pin, will be, which have been selected in here, either for motor 1 or motor 2. You see, for motor 1 we will have it EN12, and for motor 2 we will have it EN34. Whichever it is will come here, and pulse width modulation that you have sent will go to that motor, and motor will rotate at that speed. And that's the end of function. The code is now running. Now here is the demonstration. Motor 2 at 175. Motor 1 is fully. So now motor 1 is stopped. As you can see, motor 2 is still running. Now motor 1 slowed down at 170, and motor 2 is at the maximum. Motor 2 now is stopped, and it will wait for the loop to go, but motor 1 is running, as you can see. Because motor 2 have not been controlled, now it's stopped, waiting for this stage at 170 pulse width modulation. Please make sure to subscribe by clicking at the subscribe button in here. Thank you. Thank you for watching the tutorial from Robojax. If you learned something and found this useful, please thumb up, as this will help my video in the search algorithm of YouTube. If you have comment or question, please post it at the comment section below. I try to answer and reply. And don't forget to subscribe so you get updates of my upcoming videos.